Hello guys, I hope you are doing well. This is Thomas from Skill Lab, and today we'll see a beam analysis tutorial. The same thing with our previous videos, like a little bit different beam structure. So I hope you will enjoy the video, and I want you to stay with me. So our today's beam looks like this. Here we have point A, and we have point B, point C, point D, and point E. So the beam is supported at point B and at point E. As you can see, we have a uniform distributed load from point A up to C, which is 100 pound per feet, and also we have a moment here, 1,200 pound times feet. So what we will do is we will take this from A to B as one line, from B to C as 2, 3, 4. So we do have one line, 2, 3, 4, right? So what we'll do is we will tell SolidWorks we do have 4 lines here. Let's go in, right? Let's go new, part, sketch, this, form plane. So let's sketch this one. We do have 4 lines, right? 1, 2, 3, 4. So let's give this a dimension. We will see their dimensions in the drawing, but before that, let's just make it like this. So yeah, the first one is 2, 4 feet, 1, 1, right? So we don't have 2 here. We don't have here 4. We don't have 1. We don't have 1. Okay, so let's exit this. Let's go to element. Like if you don't have this thing, just right click here and go to the tabs and scroll down, and you will find elements here. So let's go structural member. Let's select this one. Wow, too much, right? We don't need this thing, guys. Let's delete this. So let's draw our own beam like this. Yeah. Let's say this is our beam with this 4 lines, and like as I always say, this one is in the Z and X direction, so we need to change this one into Y. Just right click here and rotate your part 90 degrees. So if you check it now, you can see it like this one was in the Z before, but now it changed it into Y. So let's go in simulation and let's new study. Let's make this beam analysis 9. So we don't have 4 points, right? So before we fix our beam, let's assign a material. Here what I want you to focus is in our manual calculation, we don't include a material, right? In SolidWorks, it doesn't make a difference, but in order to proceed into the simulation part, SolidWorks wants you to assign a material, so that's why we are doing it. It doesn't change the value or the shear force or the bending moment diagram that we calculate using manually. So let's go to the fixtures, fix the geometry. So this beam is supported at point B and at point A, right? At this and at this, right? So let's make this. Let's select this joint B, along the form plane. So here we have this force. Let's go and increase the dimension of the arrow so we can see it easily. This one, right? Good. And the second supporting forces. Okay, let's check this one. Okay, along what? Along the form plane. Here we have this one, and then we do have 500 here. Yes, click. Oh, we are doing great, right? Are you with me? I hope you are enjoying the lesson. So let's apply the uniform distributed load first, 100. Yeah, don't forget this is in pound per feet. So we will tell SolidWorks this is in pound per feet. So let's go to the external loads, force, and it was on the beam, right? So let's select this, and it was from point A up to C. These two things, this one and this one, because the load covers A up to C, the area. It's gonna be along foam plane. This was what I was talking about. Let's turn this into IPS. So let's make this per unit length, and let's go and select this one. How much was it? 100, right? 100. But one thing that I want you to focus here is, let's make this 500 first. I think the load is uniformly distributed, but it's in the upward direction. So we have to make sure that we check this thing reverse. I think we're done, right? Okay. We only left with one thing, which is moment. 1,200 pound-feet. The same thing, right click here and go to force, and here we have point, because which is located at the point D. So let's select this joint point D along the foam plane. So this moment is in the Z direction, yeah? In the direction 1,200. Before that, don't forget this, guys. We should make sure that this is in IPS, okay? We should make sure that this is changed from SI into IPS. From SI into IPS. So let's go and make this 1,200 pound. Am I right? Yeah, pound feet. So let's increase the size to make it more visible. It was this direction, okay? We're done, guys. This is simple. So if you see the things that I was doing, they were like simple. Knowing the manual calculation, or knowing solving the things on paper is also good. The thing is, if you want to know the concept, you don't have to waste your time writing a lot of exercise, okay? You can just follow the steps that I was doing right now. So let's go and run the study, and let's see first the reaction forces. Let's click at results, right click, and let's go to list result force, and let's select the joint, this one and this one. Before that, we don't have a size, so in this thing, if you see here, they are in pound, so let's make this thing in pound. Update. You can see 300 and 300. What does it mean? We are still doing the same, so we don't have to worry about is it correct or is it not, because they're correct, you know. They were designed deliberately, so you should have to just focus on the concept, the creativity part of this thing. You don't have to waste your time making a calculation, writing a lot of papers, okay? So just know the steps in SolidWorks and you can solve it easily. So let's check this one, and let's see the shear force and bending moment diagram. Let's see the shear force. Let's make this 100. Let's make this show maximum and the minimum. Let's make this floating and this thing 1. So let's see it. That's it. As you can see, here we have this thing, and here we have this thing. Like these are the shear. One thing that I want you to tell you, like still they are in pound, so we need to make sure that this thing is also in pound. Let's change this LPF. So yeah, 300 and negative 100. You can see it like this, right? This is what we have, guys. You don't have to worry. What I'm saying, you don't have 300, 100, 100 and 300. So these are the results that we get. And then next, let's see the bending moment diagram. Bending moment diagram, let's change this bending moment, and let's make this 100. This thing also in this way, show maximum and minimum. So float 10, and this thing is 1. You can see, guys, trust me, this is simple. This is simple. You don't have 900, you don't have 900. You don't have 300, you don't have 300. The sign is, it's all about sign convention. They are the same, okay? So let's see this thing in this way too. So that's it, guys. If you enjoyed the video, try to hit the subscribe button and try to share with your friends if you think this is valuable for you. And like, we'll try to come up with different lessons like this in another parts of mechanical engineering. We'll try to cover as much as we can. So stay safe and have a nice weekend. Wish you all the best, guys.